Okay, so welcome to all. Today we are going to discuss in nuclear reactor. Mainly, I'm talking today about fission reactors. There we used to tell critical mass, is criticality and all. This already detailed in my one video that. Video link will be popped up here. You can click and you can see in details. So today basically I will show you the fundamental concept to calculate the critical mass. Okay, so this is, I am only very shortly I am explaining. So as I told, that actual video link I will be giving you, so you can see in details. There I have detailed the things in I described in detailed way. Okay, so this is the things. Let me take one. So this is the equation which is describing the neutron atom interaction. Okay, so something it will be scattering, absorbing. Okay, sorry, I have to go to the previous slide. And this is the Fick's law. Okay, this is the Fick's law of diffusion, where this J is defined as minus D. It's a diffusion coefficient into gradient of the neutron flux. So from this concept you can establish the diffusion equation. So this is the rate of change of neutron neutron with respect to time, which is nothing but the production and the leakage and the absorption. So we already from the Fick's law we understand that the leakage term is this one. So actually here one minus sign is there, so this minus plus, and this is the production term. Okay, and this term is the absorption. So you can see that video. I'll give the video details here. While we will be playing this video, that will be popped up here. You can click that video and you can see in details. So this sigma A is called the macroscopic cross section. Okay, so with that, this is your general form, means the instantaneous form of diffusion equation. So I have for criticality means for sustainable chain reaction. So chain reaction will keep on continuing. So for that, this rate neither should increase nor should decrease. That means in the successive means not like that. What I mean to say, in successive fission, the number of neutron will be left out for doing the next generation fission after absorptions or leakage and all these things, that should remain constant. Okay, say for second time fission, N2 neutrons are left out, and in first time it was N1. Then in third collision it is N3, then N2. So these all difference will be constant. They keep on. There is a sustainable chain reaction, not exponential chain reaction. Okay, because we know that we need controlled chain reaction. So in such case, if the change of the del n, if the del n is constant, then the differentiation part will be 0. So with that, basically we will be solving the diffusion equation. So wait, actually system and okay, so now you see, so this is the, as I told, if your del n as the rate of change of neutron in successive fission, it is constant, then this del n by del t is 0. So that's why I write like this. This is the final equation, diffusion equation for criticality. And now we know the production term. We know the production. This is the production. So if my K for criticality, K should 1. Okay. For bomb, K should be greater than 1. So now the production will be absorption K times of the absorptions. So it is substituted and it is coming like this. So this term is denoted as B square, which is geometric buckling. Okay. So now solving this, I am not going to the details method of solving, because you can do it. Okay, so this is very simple. So here the excitation part is 0. So excitation part is 0. This part is 0. So that means there is no excitation. So there is no particular integral. So only complementary function will be there. So you just so the auxiliary equation is equal to d square minus b square. D square plus b square is equal to 0. So d is equal to, so d is equal to I times, imagine I into b plus minus. So with the boundary condition and with the boundary conditions and all, if you solve, so finally the general solution of this, it will come like this, and this c is a arbitrary constant. And now we can assume, if this the r is the radius, so at radius r the flux will vanish. Okay, so at r is equal to r0 basically, so at r is equal to r0, this phi is equal to 0. So if you put here, so we will get like this, because the general solution of sin theta is equal to 0 is equal, that is means theta is equal to n pi. So the nearest value of b is equal to pi by r0. Okay. So now the critical volume. So as based on the criticality, because considering the criticality, I have assumed all these things. Boundary conditions are like that, and I have solved for that. So B is equal to this one. So the critical volume, that is equal to, here I considered the spherical coordinate, a spherical shape. So you can do it for any shape. So this is, volume is 4 by 3 pi r0 cube. So here r0 cube is nothing but pi cube by b cube. Okay, pi cube by b cube. So 4 by 3 pi. So here 1 pi cube it will be coming. So pi to the power 4 by b cube. Okay, if you substitute all these things, it is coming approximately 130 by b cube. Okay, so this only I solved, you see here, same thing. So it is like this. So this is my critical volume. Now we have to find out, as I told, in we are going to find out the critical mass. So say that critical mass m we want to find out. So if you keep that mass in that volume, and if I initiate the if I activate the neutron initiator, so the sustainable chain reaction will be continuing. So based on the enrichment, we know because here this fission will be this here as it is a spontaneous fission, so it will be uranium 235. So we know based on the enrichment, we will be knowing the density of it. Say the density is rho. Okay, so which is nothing but density is equal to mass by volume. Okay, so this is mass by volume. So my critical mass will be basically rho times my critical volume. So which is nothing but, for spherical reactor, this is 130 rho divided by b cube. Okay, that means for a spherical reactor, if you know the density of uranium 235, and this for the geometrical buckling you can find out based on all the parameters. And for this case, if mc gram of uranium 235, if it is kept within VSP cc of volume, and that time if you activate the neutron initiator just once, then your chain reaction will be sustainable. And this is the procedure to find out the critical mass and critical volume. So hope this will be useful for you all. For any details, any queries, you can in description my contact details will be there. You can write to me anytime. Thanks a lot. Thanks for your patience.